about units of measure. Today we're going to jump into units of time. These are the units of measure that you're probably the most familiar with. So we know that we can measure time in something as small as seconds, and we can measure it in years or decades or even bigger, right? So we're going to start small and then work our way up for today. Thinking about this clock, we know that there's 3 different units that we can measure using the clock. We can use our smallest unit, which would be our seconds, which is that red hand on the clock. We can use our minutes, which is that bigger of the 2 black hands on the clock. And then we can also use hours, which is that smaller of the 2 black hands on the clock. So if we were to look at this image of the clock, we could tell the time is in the 4 o'clock hour because it's in between 4 and 5. It's 30 minutes past the hour, which in this case is 4, because our minute hand is pointing at the 6, which we know if we count by 5s would be 30, right? 5, 10, 15, 20, 25, 30. So we're at 4:30. And then we can also measure the seconds by looking at that red hand. And if I look at that, it looks like it's just past the 10-second mark, and it looks like we're at 11, 12 seconds. So our time on this clock is 4:30 and 12 seconds. Now let's think about how these units relate to each other. How many minutes are in an hour? You guys already know this. I don't need to go over that. There are 60 minutes in an hour. Now let's think how many seconds are in a minute. This you know as well. There are 60 seconds in a minute. Now I want you to think, how can we take that information that we know and figure out how many seconds are in an hour? If we know that there are 60 minutes in an hour, and we know there are 60 seconds in a minute, 60 seconds in a minute, then we can use that information to find out how many seconds are in an hour. To do that, we would do, let me scooch this down so you can see, 60 times 60. We know 0 times 0 is 0, and 0 times 6 is also 0. Moving on, I'm going to account for my place value. I'm going to add a 0 before I move on. So 6 times 0 is 0, and 6 times 6 is 36. If you're like, Ms. Sharma, that was a lot of work. You could have just used your understanding of place value. You're totally correct, and I hope you did that. So we know that there are 3,600 seconds in an hour based off of that information. So let's try to actually solve some problems using these different units of time. Let's take a look at this word problem first. Larissa spent 2 hours on a science project. Cliff spent, not 2 hours, this should say, sorry. Larissa spent 200 hours on a science project. Cliff spent 200 minutes. Who spent more time? So let's figure out how we could relate these 2 pieces of information. We've got hours and minutes that we're comparing. We want to kind of get to the same units so that we can have a better understanding of how these units of time relate to each other. So let's start by making a table to think about, okay, well, how many minutes are in a couple of hours, right? So we'll put hours on one side and minutes on the other. In 1 hour, you guys already know that there are 60 minutes. So in 2 hours, then we know that there would be 120 minutes. Now, I could keep going, but I know that my problem says Larissa spent 2 hours, so she spent an equivalent of 120 minutes on her science project. So Larissa spent 120 minutes. Cliff, he spent 200 minutes. So who spent more time? I already know that the answer to that would be Cliff. Cliff was the one who spent more time. Cliff. All right, let's move on to thinking about some bigger units of time. Let's think about using a timeline to help us think about how the way that weeks and days relate to each other. So I've got W for weeks and D for days. So I know that 1 week is this space here between 0 and 1, right? However, 1 day is much smaller than that, right? 1 day is only 1/7 of a week, right? Because there are 7 days in a week. So I can kind of see visually how weeks and days relate to each other when I use this number line to represent that data. So let's think about 15 days and 2 weeks. I want to use an inequality symbol here, right? Greater than, less than, or equal to to compare these two units of time. So 15 days and 2 weeks. Well, I know that 1 week has 7 days in it, so that would be 14 days, right? So now I can compare 15 days and 14 days. Which one's greater? Obviously 15 days. Let's look down here and compare years and months, right? I know 1 year is only equivalent to 1 month, 12 months. So 1 month is 1/12 of a year. So let's think about how we could figure out how many months are in 4 years, as this problem asks. This problem says 4 years equals how many months? Well, I could do a couple different things. I could set up a table, or I could multiply, right? Or I could continue this number line if that was something that seemed to work for you, right? So if I use a table, I would have 1, 2, 3, 4. These are my years. And then my months, I know there's 12 months in 1 year. So that means there's 24 months in 2 years. If I keep adding 12, I see 36 in 3 years. And lastly, 48 months in 4 years. So I could write that there are 48 months in 4 years. Alternatively, if you just did 12 times 4 equals 48, that's awesome. That works as well. All right, my friends, so that's it for our video today. I know you're pretty familiar with units of time, and so what we're going to do today actually is create our own schedules and then think about how we can relate these schedules to different units of time. So I hope you have a lot of fun with it, and I can't wait to see your work. Thanks, guys.